how do you factor x cubed plus 27? So let's look at this problem here. So we have, this is question 6. I want to factor x cubed plus 27. So how do you factor this? Well, what we can see here, like upon first expansion, you can think of this as there's only 2 terms here, and having 2 terms is not the greatest thing sometimes, because how do we usually approach factoring? Well, we approach factoring using 2 types of kind of approaches here. We can use a decomposition method where we break down usually a third, the second term in a trinomial, and then we break it down into 2 different terms to see if we can find some common factoring. We can approach this using simply common factoring, but as you can see, x cubed and 27 do not have like terms, right? So you can't common factor here. And we can also approach this using kind of factoring by inspection. So I don't see that the product of 2 numbers is going to equal something that can be summed. So in this case here, these don't apply. However, whenever we have 2 terms in a kind of a factoring question, you can think of this problem as either a difference of squares problem, or in more advancedly, in this case here, we have the sum or difference of cubes question. And the reason why we can think of this as that is because of this giveaway here. This exponent 3 means that we don't have a difference of squares, because difference of squares would have the power of 2. So we have the sum or difference of cubes here, and the cubes here is going to give us the giveaway because our exponent is to the power of 3. In this case, we have the sum of cubes, right? Because again, this here is an addition sign here, so that's another giveaway. So therefore, we have something called the sum of cubes. And this here is a special type of, we use a special type of formula to factor sum of cubes here. And let me write this out for you. So sum of cubes, I have some type of a cubed, or x cubed in this case, plus b cubed is going to equal, and b cubed would be this term here. And what we can do is we can actually check that this here is a difference of cubes because of this term here. 27 here, if I cube root this 27, I know that cube root of 27 is going to equal 3. Or, yes, it's going to equal 3 here. Because 3 times 3 times 3 is equal to 27. So let me write on the side here. The cube root of 27 is equal to 3. So therefore, the sum of cubes, we can use this and get a very, very nice equation here. So back to the formula, we have a cubed plus b cubed is going to equal a plus b times a squared minus ab plus b squared. And this here is going to be our formula for the sum of cubes. Now what we can do here, we can use this formula to solve for this guy here, right? Well, we have x cubed plus 27, right? So what is this going to equal? Well, this is going to first equal a plus b here. And a plus b here is simply just the cubed root of these guys here. So if I cube root x here, let's do an aside here. If I cube root x here, well, I cubed root 27 already, which is going to equal 3. And let me do this in a different color because this is some aside stuff here. Let me do this in yellow here. So let me see. So the cube root, sorry, I don't know why my pen is like this. Just working before, oh, I'm on the eraser. That's fine. Okay, so if I have the cubed root of x here, of x cubed, well, simply the cubed root and the x is going to cancel out, right? So if cubed root here is simply just equal x. And if we have the cubed root of 27, well, I told you that it was 3 times 3 times 3, so this will equal simply just 3, right? Which means that a here is simply this term here, so it's simply just this term, the cube root of this term, which is simply just equals to x. And then we have b here, which is the cube root of b, so cube root of 27, I said it was positive 3 here, so this is going to be x plus 3, times a squared. So a now here is the first term, so we have x here is our first term, which is a, well, it's a squared, it's simply just x squared, right? So this is x squared minus AB. So what's AB here? I know it's x and 3 here, which is A and B, right? Because we wrote x and 3 here. So I can say A times B here is 3x. Oh, sorry. And then we have B squared here, which is simply just this term squared, right? So we have B, if B here equals 3, then B squared is going to equal 9, right? Because 3 times 3 here equals 9. So we have this guy here. And this will be our factoring for this problem, right? So this here is x plus 3 and x squared minus 3x plus 9. And this here is our solution for this problem. How do you factor this? Well, we factor it using the sum of cubes. And this here is our problem. Usually this trinomial, you could try to actually factor this out here, but usually, and I say usually, this trinomial is not factorable after the sum of cubes. So that is going to be how you finish this problem. Because this, again, you can try to factor this, but this isn't factorable. You can check this by simply taking a times c here, which is 1 times 9, which is 9, and no product of 9 is going to sum into -3 here. So we can visually say that this here is going to be unfactorable. So this here will be the factored problem of x cubed plus 27. And as you can see, this solution here is correct because you have x plus 3 and x squared minus 3x plus 9. So this solution here is correct. Good analysis.